Pythagorean theorem is of course very convenient to have in many places, and this is a interesting way to prove it. If you take a square, subdivide it into two arbitrary parts a and b, and you do this on every side of this initial square, all these points will specify four right triangles with their hypotenuse facing the interior here, and of course this area, which is also happen to be a square, and its area is c squared. Then we can make this manipulation to take this blue triangle and move it down here so it sticks to this side, and then a similar movement of this green triangle to this side so it sticks here. And then we take this portion over here and move it to the right. So we end up with new configuration like this, and clearly the interior, which was c squared, is now gone, but now we have two new squares with sides b and a, so they both a squared and b squared, so therefore their area has to be the same as c squared. So that's your proof of theorem right here. And we also have definitions of fundamental trigonometric ratios, with the sine equal the opposite cathetus of the right triangle divided by the size of hypotenuse, and cosine with adjacent divided by hypotenuse, and then the tangent, which is the relationship between the opposite cathetus divided by adjacent cathetus. And of course this is the sine wave, which comes from 0 and reaches 1 at 90 degrees, or pi divided by 2 radians, and so on. So it's periodic function. And the cosine that starts with 1 and comes to 0 at 90 degrees. And this is the tangent graphic that hits those infinity values of the positive and negative infinities at every 180 degrees. So these are well-known values for specific angles. So we can actually try printing square root of 3, and then from here you can see that square root of 3 could also be found by using the result of sine of 60 degrees. So we can try it like this, and here we have our 60 degrees converted to radians. Compute the sine, multiplied by 2, and so this should be square root of 3. I press Ctrl F5 to run this code, and you can see that this is exactly what we're getting. So both outputs taking square root directly and using sine to compute it gives us the same result. So there we also have some other functions deriving from sine and cosine, cosecant, secant, cotangent, and many other formulas well known in trigonometry, like these identities. But don't worry, this will not be on our test, but occasionally it's a good reference for us to have when doing our part of the job, when writing code that actually makes it all work in a running program.